Okay, this is the other aspect of the modular arithmetic. Construct a table for multiplication in modular 7 on the set 2, 3, 5, 6. Use the table to solve the following equations. M operation M is equal to 2. Then n operation bracket open n operation 6 is equal to 3. So we are going to construct a multiplication table in modular 7. We are going to construct a multiplication table in modular 7. Here a set has been given to us, which is what? 2, 3, 5, and 6. Let's say they didn't give us the set, but they gave us only modular 7. Anytime they give you the what? The modular, then you start from 0. So if it is modular 7, then you start from 0, 1, 2, 3, 4, 5, and 6. You will not get to the 7. You limit it by 1. But in this case, the set has been given to you. So we are going to use the set given to us to construct the table for multiplication. Okay. So this is the multiplication. We have 1. Sorry, we have 2. We have 3. We have 5. And we have 6. Down here, we also have 2. We have 3. We have 5 and 6. So we are using this set to construct our table. So this is what we have. This is what we have. Thank you. Okay, this is what we have. So it's multiplication. So we are going to have 2 operation 2 mode 7, 2 operation 3 mode 7, 2 operation 5 mode 7. So 2 times 2 is what? 4. 4 mode 7. So the result we are going to get is less than the modular. So you take it like that. So 2 times 2 is what? 4. Here we don't have any formula. So you go by the multiplication. So if it is addition, then you say 2 plus 2. If it is multiplication, then you go by 2 times 2. If they give you a formula like my previous video, for example, if they give you a formula like m is equal to n operation m is equal to n plus m plus 2, if they give you a formula like this, then you go by this formula. But in this case, we don't have any formula. We just go by 2 times 2, 4, 2 times 3, modular 7. Okay. So 2 times 2 is 4, which is less than the modular. So we put the 4. 2 times 3, which is 6. 6 is less than 7. So the answer here is 6. So we're going to have 2 times 5, which is 10. 10 is bigger or higher than the modular, which is 7. So how many times will 7 enter what? 10. 7 will enter 10 only once, leaving a remainder of what? 3. Leaving a remainder of what? 3. So we're going to have 3 as our answer. So 2 times 6, which is 12. 2 times 6, which is 12. How many times will what? The modular, which is 7, will enter 12 only once, leaving a remainder of what? Leaving a remainder of what? 5. Leaving a remainder of 5. Then we come to this side. 3 times 2 is what? 6. 6 is less than the modular, so 6. 3 times 3, 9. 9 mod 7. How many times will 7 enter 9? Once, leaving a remainder of what? 2. 3 times 5, 15. How many times will 7, the modular, enter 15? 2 times, leaving a remainder of 1. Then we take 7, 3 times 6. 3 times 6 is 18. 18. How many times will the modular, which is 7, enter what? 18. 2 times, leaving a remainder of what? 4. Then 5 times 2, which is 10. How many times will the modular, which is 7, enter what? 10. So 5 times 2, 10. 7 will enter 10 only once, leaving a remainder of what? 3. Then here is 1. Here is 4. Here is 2. Here is 5. Here is 4. Here is 2. And here is 1. So you can cross check. That is our table. Now use the table to solve the following equations. So we are going to have m operation m is equal to 2. So which means the number we are going to use here, that is the vertical side, should be the same number we are going to get at the horizontal side. So when we use 2 here, it should be operation 2 to give you 4. When we use 3 here, it should be 3 operation 3 to give us a 2. And this is it. So 3 operation 3. So it's mm. So we are going to have 3 operation 3. So mm. You see the same number 3 3. You can't have 3 5. No. 3 3 or 5 5 or 6 6 or 2 2. Okay, so when you come to the 3 side, 3 operation 3 will give us 2. So 3 operation 3 will give us 2. So 3 operation 3 will give us 2. So this is the answer. So therefore, 3 operation 3 will give us 2. So to find the true set, n decide that n is equal to, in this case is m. It's m. M is equal to 3. M is equal to 3. Now I is n operation bracket open n operation 6 so give us 3. So give us 3. So the number you are going to get here and the number you are going to get here should be the same. So end 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 end. So let's pick 2. Let's start with 2. So when we pick 2, so 2 operation 6 to give you what? 3. So we start with the bracket. So when we put 2 here, when we put this 2 here in place of this n, we are dealing with the bracket first. Board mass, we deal with the bracket first. So put 2 in place of this n. So 2 operation 6. 2 operation 6 is 5. So we are going to have n operation 5 here now. That's the answer. So give us 3. So since we put here 2, we are going to pick 2 again. So 2 operation 5. So it's 2 operation 5, 3. So 2 operation 5 is 3. So it's true, it's 3. So therefore, n decide that n is equal to 2. So when you put in place of what? N, when you put 2, you are going to get what? 3. Thank you very much. So we have two sides to modular arithmetic where they will give you the formula. Like my previous video, where they will give you the formula, you use the formula to fill the table. And the other side is that they will not give you the formula. If it is multiplication, then you go ahead and multiply, like in this case. If it is addition table, you go ahead and what? Add, like here. Thank you very much. Have a blessed day.